as an amount of light coming out from a tiny bulb. And the question that you have been asked is, how much of the light is falling on this surface? So, before you calculate the light falling on this surface or the flux falling on this surface, you should know the total flux which is coming out from this. Total flux is known Q by epsilon naught. And what is the total solid angle around that point? This is a point. What is the total solid angle around that point? 4 pi. So 4 pi solid angle corresponds to how much flux? Q by epsilon naught. And your job is to, now your job is to calculate the solid angle subtended by this surface. Find this solid angle. I think you have understood how to solve the problem. Just calculate the solid angle subtended by this. Then you know, for 4 pi solid angle, amount of flux is Q by epsilon naught. For this much solid angle, amount of flux is this. Simple unitary method. Total charge delivered by a battery has to be 0 in all cases. So the battery will deliver some positive charge only when it can deliver equal amount of negative charge. Since this end is not connected to anything, so this terminal, means negative terminal, will not be able to deliver any charge. As a result, from the positive terminal also, no charge will come out. Have you understood this point? Total charge delivered by a battery has to be 0 in all cases. Okay? So if the positive terminal fails to deliver any charge, then the negative terminal will also not deliver any charge. Okay? So I will have to connect it to the ground. So now I have connected it to the ground. So the battery, if it delivers plus Q charge to this body, then it has to deliver minus Q charge to the ground. So minus Q charge will move to the ground and plus Q charge will appear on the body. Okay, if you consider two plates kept parallel to each other, and to one plate you have given Q1 amount of charge, and to the other plate you have given Q2 amount of charge. All of you know that a part of this charge will be stored on the inner surface, and on the outer surface remaining will be stored. Which charge will you put in place of Q? That is the question. Will you put the total charge, or will you put the charge appearing on the inner surface, appearing on the inner surface of the positive plate, or charge appearing on the inner surface of the negative plate? The answer is, this Q is the charge appearing on the inner surface of the positive plate. I have already told you that these electrons are almost free. So a small electric field will liberate these electrons, they will come out, they will become absolutely free now, and they will move opposite to the direction of electric field. This is the direction of electric field. Electrons moving in this direction. Electrons, they have become free and they are moving opposite to the direction of electric field. Okay? And they cannot move freely. Reason is, they are moving in a space mostly occupied by these positive ions. Okay? So these positive ions are occupying the space. Most of the spaces are occupied by these are big positive ions. Okay? These positive ions do not move. They do not move. So during motion, these electrons will randomly collide with the positive ions. Positive ion means a whole atom minus 1 or 2 electrons. Okay, so first thing that you have learned, the electrons flow during flow of time. Which electrons flow? The electrons which come out from the outermost orbit of the atom. Why do they come out? They come out only when you apply an external electric field between the two ends of the conductor. Then, do they flow freely? Answer is no. They flow, and during their flow, they undergo random collision with the positive ions. What is happening at the point B? Current is going into the plane of the board. Just consider this. At the point B, current is going into the plane of the board. And at the point A, current is coming out. Current is coming out, is going like this, and it is going into the plane of the board. Current is coming out, going along this line, and then going into the plane of the board. So at this point the current will be represented by a dot, and here the current will be represented by a cross. At this point current is coming out, then going along AB. At the point B, it is again going in. It is going in and flowing through the back of the board. Again at the point A, it is coming out. Is this drawing clear to all of you? You can just consider this book as the loop. This is AB, current is flowing in this direction. At this point it is going in, so that's why there is a cross at this point. At this point it is coming out, so that's why there is a dot at this point. Now, using this simplified diagram, we can easily indicate the forces. What will be the direction of force exerted on this element? So magnetic field is this. This is the direction of magnetic field. Then at this point, this is current. Current is going into. Magnetic field is in this direction. This is the direction of magnetic field, B. Current is going into. So what is the direction of force? This is ABC. This is the force acting on the edge BC, and then again apply for the edge DA. Magnetic field. At this point current is coming out. Current is coming out. Current is coming out. So what is the direction of force? Direction of force is given by the stretched out thumb. This is the direction of force. So this is FDA. A small current element ideal. What is the direction of magnetic field? What is the direction of magnetic field at the center due to this current element? What is the direction of magnetic field? See, current is in this direction. So at a point above this, means at a point outside the circle, it is inward. Then at a point inside the circle, it is coming out. So at this point, it is dot. Due to this, okay. Consider any other. Consider this current element. This element, current is. You can see current. So at a point outside, it is outside this circle, the magnetic field is perpendicular to the plane of the board going into it, but at a point inside the circle, it is coming out. So due to this also, it is dot. This B that I am writing here, or the B1 that I have written here, or B2 that I have written here, is not the magnetic field only due to the currents enclosed by Ampere's law. Not that. It is the magnetic field due to all the currents existing both inside and outside the loop. Long solenoid means, long solenoid obviously it stands for infinitely long, but we can use the result that we get now for a solenoid having a cross section negligibly small with respect to the or when compared to the length. So you have a solenoid, obviously not infinitely long, but cross section is sufficiently small compared to the length. Okay, in that case also we will be able to use this result. Okay, a long solenoid carrying current I. What is the effect of induced EMF? Current will flow. Okay. Consider a situation where you have induced EMF, but you have not made or you have not arranged for a convenient path through which current can flow. Okay, try to understand this point. By moving something in a magnetic field, you have induced EMF in it. As a result of EMF, current will flow. But you have not provided the current with convenient path through which it can flow. In such case, the current will choose its own path. And obviously current will choose low resistance path. Means current will be high and it will produce immense amount of heat, large amount of heat. This type of current is called eddy current. A ring, say with a handle. Okay, you are taking the ring inside the magnetic field and then taking it out. Okay, so in this, motional EMF will be induced. Reason is, flux associated with this will continuously change. Because of what? Because of the area which is inside the magnetic field. Okay, so as you move the ring inside, flux will change, EMF will be induced. And what will be the result of that EMF? Current. In which direction will current flow? In this case, in which direction will current flow? All of you know about Lentz's law, that current will flow in such a direction that the cause is opposed. So, what is the cause of induction? Flux is increasing, that is the cause of induction. So, current will flow in such a direction that flux can decrease. Okay, and flux equal to B dot A. You cannot decrease area because you are pushing it inward. So, area is fixed. You cannot decrease the area. Only option is there to decrease the magnetic field. That means current will flow in such a direction that a magnetic field in opposite direction is produced. So that means a dot magnetic field will be produced and current will flow in this direction. Okay, and when you take it out, current will flow in opposite direction. So you have induced EMF in this and you have provided path through which current can flow. It's clear? Because this is the route through which current will flow. Now with this, compare this situation. You have taken a sheet of metal, a conductor, a conducting body, a metal sheet with a handle. Okay, metal sheet, not a ring, simply a flat copper plate or iron plate, and you are moving this in. What will happen? Through this, flux will change, EMF will be induced, but current will flow. But how will the current flow? This is not a ring, this is solid plate. And the direction of induced EMF will be such that it will oppose the cause. What is the cause? Growth of current. So it will oppose by producing an EMF that opposes the applied EMF. Okay? So this happens during growth of current. Now, decay of current. You have kept the switch closed for a long time. Okay? Since you have kept the switch closed for a long time, current has attained its peak value. Okay? It has attained its saturated value so it is flowing through the circuit. Then, so that means remember at t equal to 0, I equal to I naught, then you connect these 2 points and remove the battery from the circuit. Okay, so this is done at what instant? T equal to 0. At t equal to I naught, with time, now current is falling. So since current is falling, inductor will oppose the cause of induction. Since current is falling, EMF will be induced in the inductor, and the direction of induced EMF will oppose the cause. A cause is the decrease of current, so the inductor will try to increase the current. Okay, remember current was flowing in this direction. This was the direction in which current was flowing. Okay. So this process will go on. That means energy will travel from capacitor to the inductor, and again it will travel back from inductor to the capacitor. Okay. So in LC circuit there is an oscillation. What does oscillate? The energy oscillates. Okay, between the capacitor and the inductor. Okay, and t equal to 0, the spring is stretched. Spring is stretched. Elongation in the spring is x naught. Elongation in the spring is x naught. This is the situation at t equal to 0 at the starting instant. So entire energy is present in the spring in the form of elastic potential energy. Okay. So at t equal to 0, the energy is in which form? Total energy equal to energy present in the spring plus only energy is present in the spring, elastic potential energy, half k x naught square. Is parallel to the principal axis. This is the incident ray. It is parallel to the principal axis. So after reflection, this ray will pass through the focus. This is the reflected ray. Okay. In order to get the image position of O dash, you have to draw one more ray, and this time I am drawing a ray which is passing through the focus. So since this ray passes through the focus, after reflection it will pass parallel to the principal axis. Okay. So these two rays which have emerged from the point O dash are meeting at the point I dash. Hence, at the point I dash, image of O dash will form. Is it the general form? You have got this form for a convex surface. So this formula is applicable only to a convex surface, because you have considered a convex surface. Accordingly, you have got this. But we are interested in getting a general form. In order to get the general form, we'll apply sign convention. What about u minus v plus r plus this is the formula in Cartesian. Okay. placed at a distance of, say, at a distance of 40 centimeter, where will the image fall? In such case also, you can find the focal length of the body. Okay, and then you can apply the formula 1 by v minus 1 by equal to 1 by f, or 1 by v plus 1 by equal to 1 by f. We will tackle this type of problem in this way. This one is an easy illustration. Now there will be more critical problems. Solution will use the same approach. We'll do what? We'll split this. This is a better method always. We'll split this. We'll split this and we'll show this as a combination of various lenses or mirrors. Okay, and how will you split? You will split following the path of the ray. Okay, ray. First the ray will pass through water. Exact ray diagram is not important. First the ray will pass through water. That means this water lens, this is a water lens, this is a lens but made up of water. The water lens is being used once. For each use, we will consider focal length. Okay, so first I will split. This is equal to, first the ray is passing through water lens, so water lens. Its focal length is f. Then it will fall on what? Then it will fall on the mirror. That means the mirror is being used once. So we will draw mirror. Then again the ray, now the ray will come out. That means this lens is being used for the second time. So one more. For each use, we will use the lens or mirror once. First the ray passes through water lens used once. Then it falls on the mirror used once. Then this ray will come out. It will not stick inside. It will come out. So that means this lens is being used for the second time. So again FW and FM. Then since all these are in contact, we use the formula 1 by f equal to 1 by f1 plus 1 by f2 plus 1 by f3. So what is this focal length? 1 by f equal to 1 by fw plus 1 by fm plus 1 by fw. Mostly you will see that r plus r dash equal to a, but remember that r dash minus r can also be equal to a. I will show that situation. Let us consider a ray of light falling like this. Falling on the same surface. Then I draw its path following the laws of refraction, that when the ray goes from rarer to denser, it moves towards the normal. So here it has moved towards the normal. Now it is going from denser to rarer. So now it will move away from the normal. Okay. So ray has fallen on this first surface and it has come out from the second surface, second refracting surface. So there is no basic change. Okay, the surfaces are still unchanged. Only the direction of fall is little different. Instead of falling like this, it has fallen. It has moved, it has come down from the top. Okay. Now let us again obtain the relation. This angle is R, this angle is R dash, this angle is I, this angle is I dash, this angle is A. So for the triangle AB dash C dash, for the triangle AB dash C dash, A plus 90 plus R plus 90 minus R dash equal to 180. This is the objective and this is the eyepiece. Small lens, fine. Okay, this is placed close to the, you'll have to really hold it close to your eye like this. So that means you can easily take the angle subtended at the optical center to be same as the angle subtended at the eye, because it is held like this. And then second one, you can see it has got a larger aperture, much larger compared to this. You can see the aperture of the eyepiece lens, extremely small, and it is quite big. Okay, so what you will do, what I will now discuss here, by moving the eyepiece, see I am moving the eyepiece only. By moving the eyepiece, see this objective is fixed, only you are moving the eyepiece. By moving the eyepiece, you can make the final image form at infinity, or you can make the final image form at least distance of distinct vision. By moving the eyepiece, you place the eyepiece at such a position that the final image forms at infinity. Okay, so you move this. Now through this you are seeing, and final image forms at infinity. Then that vision is called normal vision. So, what is the declination of a place? It is the angle between the magnetic meridian and the geographic meridian passing through that place. What is the condition for constructive interference? Coherent source, and path difference should be path difference. Means length of path from one source minus the length of path from the other source. If it is integral multiple of lambda, then there will be a constructive interference at that point. And if the path difference is odd multiple of lambda by 2, then there will be a destructive interference. Light is also a wave. So in the case of light also there will be interference. And same rules will hold if the path difference is integral multiple of lambda, then there will be constructive interference. If the path difference is equal to odd multiple of lambda by 2, there will be destructive interference. In the case of light wave, constructive interference means very bright light. Do you remember 100 watt? 100 watt, 100 watt. Maximum you will get 400 watt. Each point of the wavefront acts as a secondary source, and it is emitting what? Wavelets. And at what speed does a wavelet travel? The wavelet travels at the speed of the wave. So the speed at which the wavefront is traveling is same as the speed at which the wavelet will travel. This is a ball bearing. Ball bearing, you have seen cycle ball bearing. Okay, if it is very smooth, then you have kept a source here, then light will go like this, and you should expect this type of shadow. And if you observe the edge of the shadow with a magnifying glass, then you will see that it is not sharply defined. There is no sharp demarcation. Okay, so you will find around the edge only. Okay, you will find alternate layers of dark, very thin, do not expect thick, very thin, dark and bright. One or two, first 2 or 3 will be visible, the rest will be blurred. This is the objective lens. I can show you I can show here the eyepiece also. But you should know that this equally holds for simple microscope. In a simple microscope, how many lenses are there?
One.
Only one. So this is the objective lens and this is the object. Okay, so you are resolving limit of resolution. Means in front of the lens there are 2 points. Whether the lens can resolve or whether the lens can identify those 2 points as 2 different points. Now a plane which is perpendicular to the plane of vibration is called plane of polarization. A plane, in this plane there is vibration. Okay, we consider a plane which is perpendicular to the plane of vibration, and that plane which is perpendicular to this is called plane of polarization. That is the definition of plane of polarization. That means if this is the plane of polarization, if I tell you this is the plane of polarization, then you will automatically understand that the vibrations are occurring in this plane. So we can form a relation between the angle of scattering and the impact parameter. Okay, so this has largest impact parameter and its scattering angle is 0. This has 0 impact parameter and scattering angle is a maximum. 0 impact parameter, scattering angle is maximum. So that means greater the impact parameter, lesser is the angle of scattering. Door 1 is closed, door 2 is closed, bulb is glowing, and the driver gets the signal that everything is okay and he will run the vehicle. Door 1 open, door 2 is closed, and the bulb, this time the bulb should not glow. Okay, 0. The bulb is not glowing, means driver will know that there is something wrong somewhere. Then door 1 is closed, door 2 is open. Okay, the bulb should not glow. Okay, 0. Then door 1 is open, door 2 is also open, bulb should not glow. Okay, so follow this sequence: 1 1 1 0 1 0 1 0 0 0 0 0. So this is a logic operation. This is a logic operation, and this type of logic operation is called AND or AND. Now why is it required? There are 3 reasons. First reason is to keep the size of antenna small. To keep the size of antenna small, reason is, all of you know, I would have already discussed, C equal to nu lambda, and size of antenna length equal to lambda by 4 equal to the C by 4 nu, C by 4 nu. So greater the frequency, hence greater the frequency, smaller is the length of antenna, L. Smaller is the length of antenna. Okay, to transmit a power of the message signal effectively by antenna. To transmit power of the message signal effectively by antenna. Okay, so signal weak, to avoid that situation, the signal weak signal, to avoid that situation, we should use carrier wave. Okay, because power, I have already stated, power transmitted by an antenna is directly proportional to L by lambda whole square. If you use theta equal to 60 degree, then you will be wrong. You will have to put theta equal to 120 degree. It is the angle between two vectors. Okay, one is position vector of M, the other one is the dipole moment vector. Okay. How can you, obviously, to find the field at the point M, you will place a +1 charge here. Then what will you do?
Resolve.
You will resolve. Which vector will you resolve? Position. No. We will resolve what? We will resolve dipole moment vector. To get a component along the position vector and another component perpendicular to the position vector. We will resolve dipole moment vector to get a component along the dipole moment vector and another component perpendicular to the dipole moment vector. Advantage. Advantage is you have resolved P vector into two components. I will mark this component as P parallel. P parallel means it is parallel to the position vector, that's why I am marking it as P parallel. And I will mark this component as P perpendicular. Okay, how much is P parallel? P cos theta. How much is P perpendicular? P sin theta. Okay, now you have broken the dipole moment vector into two different vectors. You have broken. Now you are having two different dipole moment vectors. One is P parallel and the other one is P perpendicular. First you forget about P perpendicular. Consider P parallel only. With respect to P parallel, can you identify this point? With respect to P parallel, isn't this an axial position? With respect to P parallel, this is an axial position. Correct? And now close this. With respect to P perpendicular, is this an equatorial position or not?
Yes.
This is P perpendicular. With respect to P perpendicular, this is an equatorial position. There are three distinctly different possibilities. What are those possibilities? First possibility, all the ice will not melt. The heat present in the steam may be insufficient. How much steam have you supplied? 200 gram. You have supplied 200 gram steam. Heat present in the steam may not be sufficient to melt the entire ice. Some ice may remain unmelted. In that case, what will be the final temperature? Again you will get ice water mixture, means final temperature will be 0 degrees centigrade. This is one possibility, that final temperature is 0 degrees centigrade. What is the second possibility? Final temperature between 0 and 100 degrees centigrade. What is the third possibility? Third possibility is the entire steam has not condensed. 200 gram steam. You have passed 200 gram steam. It may happen that 150 gram has condensed and remaining 50 gram remains uncondensed? That may happen because ice is cold body. It may be able to condense 100, for example, 150 gram of steam, and it will not be able to condense remaining 50 gram. So 50 gram steam will be there inside this, and the temperature will be 100 degrees centigrade.